As we start our two-step equation solver Scratch project, it's important we back up and we look at how do we solve this two-step equation. So if we look at this general equation here, 4x plus 2 equals 10, our first step we know is we would subtract this 2 from both sides. So after we subtract 2, we simplify both sides. Now we're left with 4x equals 8. Our next step, we know since we multiplied here, we would want to divide by 4, which would leave us with x equals 2. So now we're going to follow this general procedure here. We subtracted the number alone and then divided the coefficient in order to solve by x, or solve for x. So now we'll see, instead of 4, I'm going to call the number in front of x a. Instead of 2, I'm going to call this number b. And instead of 10, I'm going to call this number c. Now, it's important that we call these letters now, because these letters can be anything. As we're running our program, somebody could tell me, okay, I want A to be 8, B to be 2, C to be 1.5. These can be any sort of numbers. So in general, our first step was to subtract this off. So we're going to subtract B from both sides. So now, since we don't know the value of C and B, we have to leave this general, C minus B. So now to get x by itself, just like we did above, just like a literal equation here, we would divide by a. And this would leave us with an equation that looks a little tricky, but isn't too bad. We had c minus b, and we divided the entire thing by a. This equation right here is going to be really important for us to use in our program in order to figure out what x is going to equal. Now, we know that there are 3 different solutions we could have as we're solving two-step equations. We could have a normal one-solution equation like we just did. We could also have an infinite number of solutions. So here's an example of an equation that would have infinite number of solutions. If your user typed in that a was 0, b was 10, and c was 10, you'll notice as we solve here, we end up getting 0x equals 0, which means any value you plug in here for x would work. So we call this equation an equation with infinitely many solutions. Therefore, if we generalize this, we'll realize if we take c and we subtract b and we get 0 here, so c minus b equals 0, and we notice that our a was 0, we're going to find that this combination right here is going to leave us with infinitely many solutions. Now our last type of solution is no solution. So here's an example of a no solution problem. If our a is 0, our b is 8, and our c is 10, you'll notice here we subtract just like we have. We end up with 0x is equal to 2. Now when we divide by 0, we know if we divide anything by 0, a number that's not 0, it's not going to be a solution. So x has no solution here in this equation. So our combination here is when we do c minus b, if this isn't equal to 0, if we get a whole number that is not 0, or any type of number that's not 0, but our a is equal to 0, we'll notice that a number divided by 0 is going to result in no solution. So this is our third type of solution. We had our normal solutions, our one solution, our infinitely many solutions, and our no solutions. So in general, as we set up our program, here's what we're going to look for. Our first step is we need to define what our a, b, and c going to be. So since these can be anything, we need to make these variables, and we need to ask for input from the users. Our next task will be solving for x. So we saw on our first slide here, when we solved for x, using these general letters, we're going to want to use this kind of equation here to figure out what x is going to be. However, we do have 2 special cases that we have to note when we're doing our program. So if c minus b is equal to 0 and a is equal to 0, there's going to be infinitely many solutions. If c minus b is not equal to 0 and a is equal to 0, there's going to be no solution. Otherwise, there will be one solution, which is our number 2 case. So you'll notice on this Scratch screen that I put my backdrop as our directions here, so our goal for as we're setting up our program. So our first step was we needed to create a, b, and c. So if we come to data, we need to make 3 variables. We need A, we need B, and we need C. And I'm actually going to click these off. You can keep these on the screen if you'd like them. Then our second step was we needed to ask input from our user for what they wanted A, B, and C to be equal to. So we know we'll find that in sensing, and we'll ask something, for example, what is A equal to? Then once they respond with something, we're going to want to set that variable to the answer they give us. So again, we're going to want to do this for all 3 of our variables. That'll kind of be our step 1. Then we said we wanted to solve for x. This gets tricky, however, because we had a lot of different possibilities down here with our solutions. So our first thing that we need to account for is if c minus b is equal to 0 or not equal to 0. So one easy way to do this is this if-else key. We can come into operators, and we can pull out an equal and a minus. You'll notice we'll have c minus b, and we can type in 0 here. So if c minus b equals 0, whatever we want to happen will happen in here. Otherwise, we'll come down here. So if c minus b is not equal to 0, or it equals anything else, this will result down here. So in this first piece, we've got our first part here, but now we have another spot where it says and a is equal to 0. So we're going to have another if-else here inside of this. We're going to say if a is equal to 0, then we're going to want to respond with a certain answer of what x equals. And I'll let you decide that. And then if a is not equal to 0, we're going to respond with a different answer of what x is going to equal. This will be put inside of this if-else loop. Then in our next piece, we have if c minus b is not equal to 0 and a is equal to 0. We're going to have another if-else. If a is equal to 0 again, then we're going to respond with x equals something special. Otherwise, if a is equal to 0, this spot down here is where we're going to want to account for our one solution. So we said there was a certain kind of formula we used with our c's and our b's and our a's. So I'm going to put this over here and let you recall that. And that will go in our last section here. So we're going to need to do a little bit of math in here, and then we'll respond with what x will equal. Alright, this is just your setup for your project here. I hope this helps. Good luck.